Right, as Rebecca said, I'm a forensic statistician, and when I first started to be a forensic statistician was I was coming to an end of a particular gruelling fellowship in the estimation of past climates, and I was reading a New Scientist, looking for a new job, and I saw a fellowship being advertised at Edinburgh in mathematics and statistics there. And it was with Professor Colin Aitken, who's one of the world's foremost forensic statisticians. And so I thought, well, that looks vaguely interesting. I put in for it and went up to Edinburgh for interview on a very rainy November's day. And many of the roads up to Edinburgh were cut off. And my little car was basically the only one to make it through. So I got the job, much to my amazement. Telephoned my mother, said, oh, I've got this forensic statistics job. She said, oh, that's nice, dear. What's that? And I had to confess that I didn't have a clue what it was about. In the years since, I've moved from Edinburgh and taken up a lectureship here at Lancaster. And I've sort of been doing forensic statistics, and I've been researching in forensic statistics. Most of my actual day-to-day work is just lecturing in applied statistics and tutoring and things like that. So this is very much a bit of external activity and research activity. And I get to go and give evidence in courts on various aspects of statistics being used in criminal and civil trials. I do an awful lot of teaching to the forensic scientists how to go about looking at their data and analysing what it is that they do and what evidence that they come up with. Now, in science, science has this particular property that scientific knowledge is constructed in such a way that how you know something is as important as that which you know about. This is also true of many other areas of knowledge, but really in science it's quite key that we know things in a way which is, well, I mean, people cite things such as reproducibility, but it's also a way not just of knowing something yourself. You have to be able to demonstrate it publicly, and it's that public demonstration of something that we call science. That is, when I've got an experiment, it's an experiment that isn't just convincing me of something, it's got to be able to convince someone else as well, and then it becomes science. And we call this as sort of a knowledge that's shared between people. In science, we're not that happy to just accept the word of experts. Really, in principle, science should go right back to the observations and to the underlying theories that back those observations up. So we don't really like having these things which I call arguments by authority. We don't believe something just because the person who is saying it is that person. We say it because we believe it because they can show us what they mean. They can show us something in the world that causes us to believe that as well. This aspect of knowledge generation is also key in law, particularly in the criminal law, where we get this sort of coming together of science and of other forms of evidence, which would go together to make up a case. And courts are quite happy to accept the words of experts. You can go into a court if you're an expert witness and you don't have to have any particular qualifications. You just have to be someone who is acknowledged by that court as an expert for the thing that they want to know about, and you can go and give expert witness to that court. And that court will accept it. It would be fine with that. As far as the law is concerned, this sort of idea of the argument by authority is focusing on the expert themselves. And it possibly looks at the qualifications of the expert, how they stand within their profession, and would look at other things, such as demeanour and other such things that the jury can see for themselves. In many ways, this is just wholly justifiable because you can't expect fact finders in a court to know all about sort of mass spectrometry or something, or some other thing that you're bringing in to the court in order to support a case. Anyway, much of this talk is sort of was sparked off by an edition in the series of the BBC Radio 4 programme called More or Less. And More or Less is a programme about statistics. And in January of last year, they had a special on, or at least a special feature, on forensic statistics and the role played by statisticians in forensic science. And this was very much in the sort of wake of furore generated by this case, which we'll be coming back to later, in the case of RVT. Now, R is Regina versus T. We don't know who the T was. This is an appeal case, and we've got no idea who the T is. We don't even know what went on. All we know about some small aspects of the evidence that was presented. And in this case, this particular appeal judgment has caused a great deal of controversy. And you'll see why towards the end of this particular lecture. Anyway, to hang their sort of, the sort of media people in More or Less, in order to hang their argument around, had to hang their argument around something, and they decided to pick upon this case. This case from 1994-1995, the infamous O.J. Simpson case. I mean, I think they were rather desperate to get some sort of celebrity angle on forensic statistics. Mostly, forensic statistics is a very mundane and boring business. And they had to try and sort of enliven it in some way, and this is how they decided to go about it. Anyway, for those of you who don't remember this case, it was this couple here are Nicole Brown Simpson and O.J. Simpson. And O.J. Simpson was a very famous sportsman from the late 80s, who was active in the late 80s and early 1990s. And in the early 1990s, it was alleged that he killed Nicole Brown. And this was a very, very high-profile case indeed. There were lots of evidence in his trial in 1995. You've got the eyewitnesses, you've got DNA, so you've got the blood stains there. Nicole had been, I think, bludgeoned to death along with her then lover, and they had been found on her front drive or someplace like that. And there were hair fibres. However, where the More or Less journalist concentrated was upon the fact that Simpson had, in the past, had a history of assaults on his wife prior to the alleged murder. Now, what happened in the case in the end was that this was a very high-profile case, and it came. The police were rather keen, or rather overly keen, to secure a conviction against Simpson. And one of the police had actually gone so far as to fabricate one piece of evidence. And the problem with that is that when evidence is fabricated by prosecuting authorities in most common law countries, and the common law countries are those of the UK, Australasia, and most of North America, in the common law countries, what has to happen when it's found that there's been this sort of fiddling around with evidence on the part of the prosecutors is that the judge has to take control of the case. The judge does what's called directing the jury. In essence, the jury just sit there whilst and they have to come up with a not guilty verdict against Simpson. So O.J. Simpson was found to be not guilty. I don't know whether he did it or not. Apparently the preponderance of evidence would suggest that he did, but we have no way of ever knowing that. However, we have got this fact here, this history of assaults. And what does this history of assaults do? Well, by itself, it's fairly meaningless until we realise that the criminologists, they tell us that 80% of men who have subsequently been found to have murdered their partners had previously assaulted them. Now, the More or Less programme didn't actually take this any further. They just left that standing there and sort of implied that it was strong evidence for O.J. Simpson's guilt. And I'm not particularly, being a forensic statistician, I'm not particularly happy with this strong evidence. I'd like to know how strong. What sort of rationale can I bring to get this 80% and this fact into some sort of perspective? What I want is some sort of value of this observation. I want something rather better than this sort of implication that there's 80% of men who had subsequently been found to murder their partners had previously assaulted them. That being, I don't take that at face value. We've got this fact. We've got the fact that Simpson has a history of assault against his wife. So what can we say from that? Could we say that there's an 80% probability that Simpson killed Nicole Brown? And I mean, that's all too an easy conclusion to draw. And in my view, it's utterly and grossly misleading. If you go around putting this sort of interpretation upon these figures, you will quickly draw very misleading conclusions about the nature and the value of this particular fact. And this is why. This is because what it says is 80% of those men who had subsequently been found to have murdered their partners had previously assaulted them. So I'm going to bring in an idea here, and this idea is it's to do with conditional probability. What we've done, in order to get that fact, you've got all these men who have murdered their partners, and you've sort of counted how many of them have previously assaulted their partners, and you found that 80% of them have done so. So essentially, what you've done is you've got all those who are already guilty, and then you found that 80% of those have previously assaulted their partners. And this is the probability of assault given that they're known to be murderers. And actually, that is the wrong figure to have. That's not of any particular value on its own in this instance. What you want, really, is the probability of murder given that you've got the assault known to have taken place. And to draw conclusions about Simpson's guilt or otherwise, we want the probability of murder given assault, not the probability of assault given murder. To confuse these two is a basic fundamental error of interpretation. And we call it a transposed conditional. It's where you're swapping around the meaning of the conditionality of the probability. To make this clear, this is one I always use for I used to have a regular sort of lecturing session of trying to tell the sheriffs of the Lothians, the sheriffs in the Scottish system of justice are middle-ranking judges, and they've got sort of various powers of being able to dispatch constables to arrest people and imprisoning people for up to 10 years and all that sort of thing in their courts, and they act with the powers of their court. And I used to give them this. And this is a particular example I used to use to illustrate how you can get these transposed conditionals, how you can get these things so very, very wrong. In the UK, we've got about, roughly, 80,000 people in prison at any one time. And of those 80,000, 70,000 are men. Criminality tends to be a male-dominated thing. In the UK as a whole, there are about 30 million men in the United Kingdom. We can get two of these conditional probabilities from these three facts. We can have the probability that a prisoner is a man. Well, that's 70,000 over 80,000, or 7/8. Or about 88%. And we can have its transpose, the probability that a man is a prisoner. Now that's going to be this 70,000 over 30 million, so or 7 over 3,000. And that is about 0.2%. So confusing these two, this probability that a prisoner is a man, with the probability that a man is a prisoner, you're confusing 88% with 0.2%. So you're really being very misled as to the relative probabilities when you confuse these two probabilities. And it's obvious that you shouldn't be doing this. This is a gross misinterpretation. Yet people do it all the time. And if given the choice, people will try to transpose probabilities. They will get a probability and try to turn it. Rather than working with the probability as it is and precisely what it is, they'll try and turn it into something that it isn't. I'll go on to a different class of evidence. This is a case I worked on some years ago, and it has a bearing on both. Well, it acts to allow us to explore the principles of how we can go about evaluating evidence, but also it ties in to the R versus T case. And it was one I was approached by a member of the detective of Northumbria Constabulary. And it was in Hexam, and it's one of these small sort of, it's a burglary committed in one of these small terraced houses, and the burglar had gained entrance and left via one of these very small lavatories with a little window across the top that he was able to climb in and get out of. And the detective involved, he'd got this shoe mark at the scene, and he got a match in type and size for a pair of shoes found in the possession of this suspect. And this suspect, for the purposes of burglary, had two other pairs of suitable shoes that you could have gone burgling in. The shoes were quite rare, so the detective thought, I need a statistician. So he came off and came up to us at Edinburgh to come and try and peel this to pieces and try and get some sort of value for these observations. There were other distinguishing features, but the examiner, the footwear examiner at the time, wasn't really that convinced that these were unique matches. So what we really wanted to do is, we know that we've got a similar, or they're indistinguishable, both in terms of size and in type, but we don't yet know what that means. So what we want to do is see what extent that this match between the shoes, and see to what extent that leads us to believe that the shoe So one of the shoes found in the possession of the suspect was in fact the shoe that left the mark on the lavatory seat that was subsequently looked at by the footwear examiner. Here are some. These are not the ones. I was never supplied with the images. These are footprints. In forensic science, they always go, and sort of in CSI, they always go on about sort of finger marks, fingerprints and things like that. Really, technically, prints are things you take for reference. Marks are things you find at the scene of crime. So you find a shoe mark at the scene of crime, and you've got a print which you take from a suspect's footwear. And typically, what the footwear examiner would like to find is that they would like to find distinguishing features. These two prints here are of very similar shoes. In fact, a similar type and similar size of shoes. And they're very new shoes. So what happens is that they haven't managed to accumulate all those little bits of damage and little wear marks and things like that that happen to shoes that make them, take them from being just a generic type and make them something which is individually distinguishable. And in this case, the footwear examiner was only able to do this, was only able to put them down to a type, wasn't able to make the statement that this was the shoe that made this particular mark on the lavatory seat. So we want some way of evaluating. It's still of value because you've got this similarity of observation, but you need to calculate what that sort of value is. Now, from the importers, we knew that 12,000 pairs of the matching shoe had been, these were imported shoes, and that 12,000 pairs in total had been imported into the UK. And we knew that the offender would have to be one of these 12,000 individuals, because we know that the offender had access to a shoe of this type. So what we could say with any suspect we've got is that there's a probability of 1 in 12,000 that the suspect is the offender, given that we've observed this shoe and the similarity of the shoe types. So we've got something like a 0.008% probability that the suspect is the offender. So how good is that as a measure of evidence? Well, we've got some problems with it. 0.008% is pretty low. You'd have to ask yourself whether you would think of that as being beyond reasonable doubt, being that's the reasonable doubt is the standard of proof needed for assigning criminal responsibility to a suspect in our system of criminal justice. Also, we're commenting upon the guilt of the offender. We're producing getting an expert to comment, to give some opinion on the guilt of the offender. And in some respects, this is something which most experts would rather not do. They'd much rather confine their comments to what the evidence is and commenting upon the observation themselves. Really, it's that sort of finding out about the guilt of the offender is the province of the jury and of other members of the court, not of the expert witness. So and we would say that this would be supplanting the role of the jury. So it's not really a brilliant figure to have as being some sort of figure that tells us about this evidence. What would happen if we did it in a different country? Let's say, what about if we did this in the People's Republic of China? I mean, they've got 25 times the population of the UK. So if we've got a shoe that was equally as popular, we would expect to have 25 times the number of shoes having been imported into the People's Republic of China. So the shoe occurring with the same frequency, that would give us something like a probability of 1 in 300,000 of guilt. And that's very different from our 1 in 12,000 probability of guilt, given that we've observed this. So why should it be that the same observation would be population size dependent? It doesn't make any sense as a measure of evidential value. So this is the objection to trying to use something like trying to calculate a probability of guilt, given that we've observed our evidence. So what can we do? We've got to solve this in some way. Got to be some figure that we can use. So we want something. We need a measure which is going to produce, is going to distill the effect of this evidence. We want it to be in a single number, and we don't want it to be affected by anything, by population, by any other factors other than the observations that we can make. And the way in which we found to do this in statistics is to look at really a way of how the evidence improves our knowledge of who did it. We look at this we can think of it as a way of looking at how the evidence changes our knowledge of the guilt or innocence of any suspect. So what we can do is we can look at the ratio of the probability of guilt before we've seen what the evidence is to the probability of guilt after we've seen what the evidence is. And this will be some way of measuring the evidential strength. So, in the case of the UK, we've got our 1 in 12,000, which is the thing that we come out with in the end, but we start off with 1 in 60 million because we've got no idea who's done this before we've observed anything. Could be anyone. So we can start with 1 in 60 million, and then after knowing the shoe print, we've seen the shoe print, we come down to a probability of 1 in 12,000, and that gives us an improvement of 5,000-fold improvement. So we can think of this as a change in the way in which we've, as a change in the in our opinion, and that change is due to the evidence. So we can take this as a measure of what the evidence is doing to our knowledge. People's Republic of China, well, okay, we've got 300,000 individuals with that same shoe, but you've started off with 1 in 1.5 billion individuals. You divide those two, and again, you get the same ratio. You get this 5,000 ratio. So we've got this ratio, and it's the same in both the UK and the People's Republic of China. So it's invariant to population size, which is a good property for a value of evidence. We're seeing the same things. There's no reason why they should be different in different nation states. And we call this thing, and we're always calculating these things, a likelihood ratio. And essentially this is the formula for it. We erect two propositions. We have a prosecution proposition, and in this case, this would be the shoe mark made at the crime scene was a shoe belonging to the suspect. And we have a defence proposition. In this case, in the case of the Hexam shoes, the shoe mark made at the crime scene was a shoe belonging to some person other than the suspect. And our likelihood ratio is the ratio of those two probabilities. So, the suspect had 3 shoes suitable for burglary, and exactly a single pair could have made the crime scene mark. So were we to randomly sample the suspect's shoes, then we would have a 1 in 3 chance of observing this similarity of sole, this mark and print match, were we to sample from the suspect. So we could put in this numerator, sorry, not denominator, as 1 in 3. For the denominator, well, if the defence proposition is true, then the shoe mark was made by a shoe not belonging to the suspect. So we want the probability of seeing that particular mark, were it true that the shoe was some person in the population who was not the suspect. We know we've got 12,000 matching shoes in the population, so we just need to know out how many shoes that is. And this took a great deal of work. This list here went on for page after page. This is based on Office of National Statistics and British Footwear Association, sort of both production and imports of shoes. And various ones were considered suitable for, and they go into bizarre detail in these lists of produced shoes. I mean, things such as scuba flippers and things like that we didn't really consider part of the viable population for committing burglary in. But all of these things, we totted up all those which were reasonable to have committed the burglary in, and we came to a total of about 97 million pairs of shoes. And that's about, actually, in reality, we could have gone for many, many more. We've got roughly, in the UK, we've got roughly about 350 million pairs of shoes knocking around. But we thought that 97 million would be a good justifiable figure that we could use here. So we go away and calculate our likelihood ratio. And we've got our numerator, a third, and then we've got our 12,000 over our 97 million. And that gets us a figure of 2,700. So we can say from this that the observation of the particular type and size of shoe is 2,700 times more probable were the shoe which made the shoe mark that belonging to the suspect rather than any of the other United Kingdom shoes. So what is this 2,700? It's quite a reasonably large figure. Well, with these likelihood ratio things, a likelihood ratio of 1 means the evidence doesn't support either of your propositions. If you've got likelihood ratios of less than 1, well, in the way in which these propositions have been set up, you are supporting the defence case. If you've got a likelihood ratio of less than 1, then you take its reciprocal and you could say that would be the likelihood ratio for the defence proposition. To get it into some sort of perspective, and this is, there's many of these sorts of verbal equivalents of what it is you can say from a likelihood ratio, but we've got a likelihood ratio between 1,000 and 10,000. So what we could say here is that the observation of this particular shoe mark, the similarity between the particular shoe mark found at the scene of the crime and the shoe print belonging to the suspect is strong support for the prosecution proposition that in fact the shoe was that of the suspect rather than any other shoe in the United Kingdom. So here, and this is what we now consider, these likelihood ratios are the things that we consider to be a sort of standard for evidential value in those types of evidence that can be evaluated, and it's not all types of evidence can be. Things such as eyewitness testimony can't be evaluated in this way, but things such as physical evidence, that evidence given to us by the forensic scientists can be evaluated like this, and we consider these likelihood ratio things of being the standard for these evidential interpretation. So we've now got a relatively simple way and intellectually satisfying way of evaluating this sort of physical evidence. So how can we come back to O.J. Simpson? Can we apply the same things to O.J. Simpson? Can we come up with and actually evaluate this, this Simpson's alleged history of assault and this fact that 80% of those men who had subsequently been found to have murdered their partners had previously assaulted them? Can we use our new knowledge to make any sense out of it? Well, I'd say that we can. What we can do, we've got our little formula here, we've got our likelihood ratio formula, we've got the probability of the evidence given the prosecution, and the probability of the evidence given the defence proposition. And this 80%, well, the 80% is the probability of assault given murder. So that really is the probability, the assault, the history of assault is the evidence, the given murder is the proposition. So that really is the numerator in this thing. So this 80% goes in the top line there. The denominator. So we've filled it in. We've got our numerator in there, and then we want a denominator. We don't know what's going on the bottom there. So what we want, well, what is that thing there? It's the probability that you've got an assault given that the person concerned did not murder their spouse. So we want the probability of observing a man who's assaulted his partner but hasn't murdered that partner. Very few men murder their partners. So it's approximately equal to seeing the probability of a man who has assaulted his partner. Approximately equal. So here, we need to go back to our criminologists. And this is where I had to do a little bit, and with the help of some of my colleagues at Lancaster University, had to inquire about domestic violence against women. And you've got a couple of figures that come out, and we know that O.J. Simpson was never convicted of it. It was just an allegation. He was cautioned, apparently, but he was never convicted of it. Well, if you need conviction rates, it's about 1.1% of the population of men are convicted at some point for domestic violence. And where you've got some case where it's more similar to Simpson's, where you've got a case where charges are not going to be brought, you're not going to get an arrest or any form of trial, well, that's thought to be about 5% of mine. This is just the nature of social statistics. They're always, people are surprisingly difficult to count, and you've always got to deal with forms of uncertainty when you're going on about counting people. So let's work out our likelihood ratio. Well, we've got our 80% over 1%. It's about 80. Our likelihood ratio could be 80% over 5%. Is our 16. So we've got a footmark. We've got a likelihood ratio of 2,500. We've been through all those workings there. If you've got DNA, well, likelihood ratios for DNA tend to get into the millions, hundreds of millions and sometimes billions. So compared to that, our 16 to 18 is not high. On our verbal scale, this would give our observation that O.J. Simpson had previously assaulted his wife, Nicole Brown. That would only give us moderate evidence that he went on to subsequently murder her. May seem imprecise, this 16 to 80, but it is a measure of the evidential value. It's a measure of what the evidence is doing rather than trying to work out a probability of guilt. And it's far less misleading than this 80% probability of guilt which we might do if we got things horribly wrong. These likelihood ratio things, well, they're fully demonstrable. It's open, you can see every stage of the calculation, thus is open to both scrutiny and criticism by those of you who might disagree. However, trying to intuit values of evidence without actually doing the calculation is, well, it's probably even worse. It is just guessing, and you can, if you don't do it properly, you can get things which are highly misleading. In this particular case, if I were to try to bring out, if I were actually involved in the O.J. Simpson case and I were to try to bring out the fact that Simpson had got this history of assault against Nicole Brown, and I were to try to do this, I'd get thrown out of court. And the reason I'd get thrown out of court is that it wouldn't be considered relevant under the rules of evidence. He was never convicted for it. He was cautioned, but he was never actually convicted. And you can't allow you can allow some things to bleed through from a person's past, but you can't allow specific offences to come through and to draw conclusions. So it would contradict some of the rules of evidence. So you get kicked out anyway, were you to try to do this. So I would never actually do it. So I don't know why the more or less editorial team decided to concentrate upon this. It's something you couldn't do anyway. Our shoe marks in Hexam. What did that do? Well, our likelihood ratio of 2,500, the defence decided on about the sort of in the afternoon of it's a very short trial, caused the defence to change their account. The suspect or the defendant told his counsel to instruct the court that yes, he did believe that the shoe that made the mark on the lavatory seat was one of his shoes. But these shoes he had loaned to a friend, presumably someone who he hoped was at large and unfindable. However, the good fellows of Northumbria Constabulary scoured the streets of Hexam and located this friend and pulled him into the court. The shoes were, I recall, I think size 8. And this this friend had shoes had feet of size 11. So the court, Northumbria Hexam assizes, had the entertaining spectacle of a man who was trying to walk in shoes that were 2 sizes too small for him. The case collapsed, or rather the case for the defence collapsed, and the suspect was convicted on a unanimous verdict in that particular case. So, what sparked it all off? Is this R versus T? Now, we don't know who T was. All we know is that T had been convicted of a murder, and that the evidence, a substantial part of the evidence, were footmarks, and very similar to the Hexam case. So footmarks found where you get in certain murders. I mean, if you've got some sort of assault involving puncture wounds, things like that, people bleed profusely, and blood is surprisingly mobile stuff. And if you are anywhere near the place, you'll get it sort of all over, and particularly over your shoes, and you'll get marks made by the sort of in blood across everywhere you go for the next sort of 20 minutes or so. It's incredibly easy to pick up these things. And Mr. Ryder of the Forensic Science Service was the examiner at the case and did a really, what I thought to be a very good job on the original evidence. It did go a bit far in some bits, but otherwise it was a good job. And what had happened was that under appeal, the judge, because he'd come up with one of these likelihood ratios, the appeal court judges didn't seem to like it that much. They reasoned largely on the grounds of precedent and some forms of argument which were quite fairly obscure. I mean, much of the judgment is, the appeal judgment is freely available. Quite a lot is redacted, so you can't really see what their reasoning is. I mean, the best of it was attention given to the uncertainty in the background data. So where you've got this population of shoes, well, you're uncertain about that. And that's, you know, that's a perfectly valid piece of criticism to bring to bear upon these cases. But otherwise, what really happened was that the Lord on the appeal case came to the conclusion that this likelihood available to the evaluation of evidence was puts it in their words, unreliable, and had rejected its use in this particular case. Now, the problem with English law is that it relies greatly upon precedent, what's gone in the past, and if a piece of evidence gets kicked out, then future cases will look towards that evidence and look towards that case to kick out similar types of evidence. So really, what's happened at the moment, in the light of this R versus T appeal judgment, is that footwork examiners have to say something categorical, such as, it was that shoe and no other shoe on the face of this earth, or they have to say something, if all you've got are class characteristics, such as make and size, or you can say this shoe cannot be excluded, but what they can't do is deliver the sort of analysis which we've given here tonight. So really, this court judgment on its own, this appeal judgment, has taken us right back to the late 19th century, where this is basically the sort of state of what the art was at the time. So we've just stepped back in time over 100 years on the basis of one judgment. Right, well, thank you for your attention.